Today we're going over lesson 4.4, which is proving triangles congruent with side angle side and hypotenuse left. So first off here is side angle side, and again a two side and the included angle of one triangle are congruent to two sides and the included angle of the second triangle, and the triangles are congruent. Now notice it is SAS, not just two sides and one angle. The angle is sandwiched or included between the two sides. So we have side 1, angle, side 2. Same thing over here, side 1, angle, side 2. Okay. Now next up, we're going to need to go over different ways we can show angles congruent. In yesterday's lesson, we did the 3-4 reasons that side could be congruent, but here there's a lot more for angles to be congruent. Well, it appears to be missing. Let me try some. Well, there they are. So we've got, first off, vertical angles congruent. Now this top reason is the most common reason from a diagram. I've got two diagrams over here that have it. Right here, angle 1 and 2 are formed by two straight lines. Right, those are the same lines, so those are vertical angles. Those are congruent. Otherwise, we have the hourglass looking one. Right? Usually it's a bow tie or an hourglass that's going to give us vertical angles congruent. That is the most common diagram of angles congruent. Other options are, we have bisecting, right? And again, whatever comes after the words what's being cut in half. So it would be segment AB bisects angle ABC, right? It's how that would look. We also have right angles, right? We have perpendiculars, we have right angles. We learned that perpendicular gives us 4 right angles, so depending on what our triangle situation is, most of the time if they're perpendicular, we want right angles congruent. But note, perpendicular is always 2 steps, right? The first step here is perpendicular means right angles. And the second step is those angles are congruent for the reason of all right angles are congruent. Next up, we have parallel, and parallel gives us 3 types of angles that can be congruent, right? We can be alternate interior, which is the most common, right? This one's for sure the most common of parallel because we'll see a lot of some sort of quadrilateral looking shape where one pair is parallel, so that's going to give us alternate interior. That's the most common. There can be situations with corresponding and alternate exterior, but it's a little more forced, and we'll see those in later lessons, more likely than not. Lastly, right, so we've got 6 reasons so far. There's reflexive. Reflexive is not used as much as it is with side, right? Because you have to have really specific looking triangles that use the same angle. In that case, angle A is used in both triangles. It doesn't happen very often. So most common ones are probably going to be alternate interior parallel. You'll see vertical a bit, and you'll see a little bit of perpendicular as well. So those 3 or 4 are pretty common. Starting off, we've got given AC congruent to CD. So our first proof here. Next, EC congruent to BC. So just label the given. I'm just kind of going through one step at a time. So we got both of those done. I don't have any more given to use, so this is one that's in the diagram. So only a 3-step one here. So we've got to just fill in what we have there. AC and CD congruent. EC and BC congruent is our given. And then in this picture, we have vertical angles. This angle here and this angle there are congruent. So we can call that, angle ACB congruent to angle DCE, or you don't need to do both, but generally when we get to writing proofs, I just like to label my diagram. You need to label the diagram if you're going to use angle 1 and 2. I could also say angle 1 congruent to 2, but you must have it labeled. If you write angle 1 congruent to 2, and there's no 1 and 2 in your diagram, I couldn't count it correctly, right? So you need to label your diagram, or you could use the 3 letters. You cannot call it angle C equals angle C, because I don't know what angle you're talking about. That also sounds very much like reflexive. So just a couple quick notes on that one. The vertical angles congruent is our reasoning. Lastly, triangles are congruent because we got side, angle, side, side, angle, side. So this is SAS congruent. And then we're going to rewrite the proof, which was CAB and CDE are congruent. And there's that, just a 3-step proof. If you need more time to write these, you can always pause the video. Next, we've got AB parallel to CD. So again, labeling, where are my parallel lines? Then we also have AB congruent to CD. So these are also equal. And this one's going to be a 4-step proof. Okay. And we've got, again, CAB and ACD congruent. So first, write out your given, AB parallel to CD, and AB congruent to CD. Now again, going through my given, I like to do what I can with the given before I look to the diagram for extra information. So AB parallel, I'm looking for corresponding alternate interior or alternate exterior. I see alternate interior with this angle and this angle. Now again, just a quick note, a lot of people see what kind of looks like right angles. You cannot make a statement about right angles if we don't have the red boxes and if we don't have something like perpendicular. So even though it might look like a right angle, we can't use that, right? It's not given in the diagram, but we can use the parallel. So those are alternate interior angles. So alternate interior angles are congruent. And again, just like last time, I can call these angles 3 and 4 because I talked about 1 and 2 last time. Or you could use the 3 letters, calling it DCA and BAC. Okay, either way. Next, I've used all of my given now, and I've got an angle and a side, and an angle and a side. I need side, angle, side, side, angle, side. This side here is shared, right? That one's reflexive. It's shared, so AC is congruent to itself. And I already gave up the reason, that is reflexive. We had a lot of practice with that in the side, side, side lesson. And now I have side, angle, side, right? Side, angle, side, side, angle, side. You got to follow the same pattern both ways. So with that, we've got triangle CAB and ACD congruent. That wraps up proof number 2. And SAS is our theme for this lesson until we get to HF. Next one, I would say try on your own. So pause the video, give yourself a moment to try to get it down. So going through this one, we have the given, really straightforward, right? Something congruent, something parallel, already marked, right? Very similar to the last one. We've got this angle congruent to this angle, right? Alternate interior again, we can call them 1 and 2, or you could do DAC and BCA congruent, or you could also call it CAD and ACB, right? They can be called by multiple names, but the same idea. Next, we have a reflexive here. So AC is congruent to itself, and that's enough information for our triangles to be congruent. So double check to see if you got that one right. Next, we've got a couple more segment steps in this one. Look, very similar to our first picture. A little bit more writing, so you might want to leave more space with number 1. C is the midpoint of AB. A little bit of abbreviating. And AB is segment bisector of BE. So SEGM is my abbreviation for segment, BIS for bisector. And we got 1, that was given. So now I'm going to go through these. Like, wait, what does midpoint mean? Midpoint means that A, C, and CD are congruent. So that's going to be my step 2. I defined what midpoint means. And write that those two pieces are equal. AC congruent to CD. Next part of my given. AD is the segment bisector of BE. So that means this line cuts this one in half. So these two pieces are equal. So BC and CE are congruent by either definition of segment bisector or definition of bisect. Really, most of these problems, they'll just tell you something bisect something else, whether it's an angle or a segment. So generally, I'm going to use definition of bisect. If it is segment bisector, angle bisector, that works for both. Again, it's whatever follows the word, right? Bisector of what? The segment. Next, I'm done with my given, and I only have two sides, right? So I'm looking, do I have a reflexive for my third side? Nope, right? But we have a vertical angle, right? Right there. 1 and 2 are congruent. And again, you cannot call that angle C equals angle C. You can do 1 and 2 if you label it, or use the 3 letters. Vertical angles congruence, or vertical angles congruence theory, right? And then that's it. We've got side angle side. Usually double check the side angle side, side 1 angle side. And that is good. So we got CAB and CDE are congruent by side angle side. I'm going to put a congruent mark there because we'll learn there's a similarity version of that as well. Next version for kind of our shortcuts is, again, very similar to Pythagorean theorem, right? If I gave you numbers for these, you'd be able to solve for the missing side. Same idea here. Basically, this one's a fancy side problem, but again, just specifically going into what does this say? This is hypotenuse leg congruence theorem. It sounds like we only need 2 pieces. However, we actually need 3. So I'm going to call this HLR theorem. And then I'm saying hypotenuse and leg only exist in a right triangle. So we need hypotenuse and leg of a right triangle and hypotenuse and leg of the other right triangle. And then the triangles are congruent. And again, notice, if you weren't sure, SSA, right, spells a bad word going the other way, right? So SSA is not a valid method for proving triangles are congruent. There is a special case, and this is the case. So if you're ever looking through and we have ASS or SSA, that's your hint that, oh, it's hypotenuse leg right triangle. So how does that look like in a proof? Now, just a quick reminder, perpendicular is always 2 steps. So you'll notice most of these proofs involving these are at least 4 steps, potentially more. So starting out, we've got given WY congruent to XZ. So that's this long segment congruent to this long segment. They kind of overlap, so it's kind of hard to draw that correctly and well. Next, WZ perpendicular to ZY. So that's what it's telling us there. And then lastly, XY perpendicular to YZ or ZY. So that's what we have here. Looks a little bit like a mess, but fill those in. Upside down T again stands for perpendicular, means we have right angle. So our first thing we're going to do is deal with those right angles, because we don't have anything else in our given we can use. So we can call this WZY is a right angle. And we have a second right angle, XYZ. So I'm going to write WZY and XYZ are right angles. Now I usually will say RT is my abbreviation for right, but I'm writing it completely out for this one. And that, by the way, was definition of perpendicular. Now, we need right triangles for this problem. So, because we don't have hypotenuse or legs without that. So we're going to say those triangles that we're trying to prove here are right triangles. So WYZ and XZY, the ones that are in our proof, are right triangles. So this is a little different, right? Instead of talking about angles congruent, we're talking about right triangles. And now we need to check that we have hypotenuse and leg. But this was by definition of right triangles. Right, we got right angles, and right angles are what makes something a right triangle. Yep. So lastly, we need to check if we have hypotenuse and a leg. Now, if I kind of drew these triangles out, so far we have this, we have hypotenuse, and on the other side we have hypotenuse. Right? We need these legs here congruent. Well, ZY is in both triangles, right? If we kind of highlighted it out a little bit, we've got this triangle, we've got this triangle. We share that bottom side. So this one, ZY, is going to be congruent to itself. So there's our second and last step. This is our leg. ZY is congruent to ZY. It's reflexive. And therefore, we have hypotenuse, leg, right triangle, right? If you're kind of tracking through the steps, we started with hypotenuse up here given to us. We've got right triangle, we got our legs, we got all three pieces. So those triangles, WYZ, congruent to triangle XZY by HLR. Right? The emphasis on HLR is that we have three pieces, just like all the other ones, side, 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 side angle, side, all needed three pieces. This one, we equally needed three pieces, right? So we got one more proof to go. Last one is given the diagram, another 5 steps, prove triangles are congruent. And in this case, they didn't give us much, so if they just say diagram, we'll take the diagram, right? Now, the diagram includes some perpendicular lines, right? These are perpendicular lines, not necessarily right angles. So we're going to say, by definition, we can call them 1 and 2 if you want to make it easier. Or, again, we've got kind of names here to help us in a little bit. So either way works. But definition of perpendicular tells you angle ABC and angle DCB are right angles. There's my abbreviation to try to squeeze it in a line. And the triangles are right triangles. Right? Because we're doing hypotenuse leg, those are the 2 steps that we get with perpendicular. Now, because we will use perpendicular in other ways coming up shortly, and I believe 3.5, we need 4.5. We need to make sure that to like do your little mini proof ahead of time to make sure we have the right pieces. So right here I've got side, side, angle up. That tells me it's hypotenuse leg. So that's why I know we need right triangles. And then this one's a leg, and this is a hypotenuse, right? And so that's how, again, doing this problem ahead of time, I know we're going to need right triangles for this step instead of angles congruent. And again, definition of right triangle. And then I already marked it on the diagram there because looking, we have a reflexive again. BC is equal to itself or congruent to itself. Or we have a shared side like that. It's mentioned probably 99% of the time. And then we've got our leg. We've got a right triangle. The hypotenuse for labeled congruent. And so triangles are congruent. ACB congruent to triangle DBC by HLR. And that wraps up today's lesson. If you have any questions, feel free to ask by email.